Today is the last lesson before we spend a bunch of time reviewing for the A exam, so hopefully you're excited about that. And to be perfectly honest, this is a bit of review as well. It's separation of variables, so it is going to be slightly more complex than what we've seen so far. However, you guys have this basic concept down already. Get the variables on different sides of the differential equation and then integrate. Example 1, I'm going to multiply both sides by y squared and multiply both sides by dx. Integrating. The integral of y squared gives me 1/3 y cubed. We'll put that constant of integration on the side with the x. The integral of 3x squared is x cubed, and then we have our plus c. We saw one like this earlier where we don't need to solve for y. We don't need to deal with square roots or cube roots or any other roots. But it is nice to kind of clear the fractions. So I am going to multiply everything by 3, giving me 3x cubed. And of course, a constant times c is just some other constant. So that's as far as we need to simplify this differential equation. Another one where we have that stupid y prime notation. I much prefer the dy dx, so that's going to be my first step, is replacing y prime with dy dx. And then separating those variables. I'm going to divide both sides by y, multiply by dx, and divide by x. Integrating both sides, they both have the variable in the denominator, so that's going to give me natural log of y equals natural log of x plus c. What we're going to do now is use those rules that we saw when we were taking e to a power that had addition, because in order to cancel those natural logs, I'm going to use e as a base for both sides. On the left-hand side, it's pretty straightforward. E and natural log cancel. On the other side, it's not quite so straightforward. But remembering that property where if we have an exponential to a power plus a power, it came from multiplication. So this e to the c power becomes a new constant that I am multiplying by. Now my e and natural log will cancel, giving me x. All right, a couple more examples. This time we're looking for a particular solution, so we're given an initial condition, but same concept. We need to start by separating the variables. When we look at this one, initially it doesn't seem like it's even possible to separate those variables because they are together in that exponent with subtraction. But if we remember our properties of exponents, the first thing that I'm actually going to do is rewrite this as adding the opposite so that we can use the properties of exponents with addition, because it's going to be easier to integrate that way than if we use the property of division. As you remember, if we have subtraction of exponents, it came from division, but I want to use this as multiplication instead. So now, what we've talked about several times now is that this is also e to the y times e to the negative 2x. Now it is possible for me to separate my variables. So I'm going to divide both sides by that e to the y. And multiply both sides by the dx. Now to integrate this, I don't want that e to the y in the denominator, so I'm going to bring it to the numerator and just make that exponent negative. Finally, I'm ready to integrate both sides. Now we could use u substitution on both sides. So I would use, if I did that, I would use different variables. I would use u on one side and maybe v or w or something else on the other so that we don't confuse them. However, we also can number sense our way through this. So I'm going to try that, especially on that e to the negative y side. So the integral of an exponential is itself, but we would have that extra negative to take care of as well. So think about taking the derivative of this, that chain rule, multiplying by the derivative of that exponent would be -1, which would cancel that negative we just put out front. And on the other side, something very similar. So the integral of that exponential is itself. Now the derivative of the exponent would be -2. So when we integrate, we have to take care of that by multiplying by the reciprocal, so that -1/2, and then we'll put our plus c. If you didn't follow that number sensing through it, let u equal the exponent, and you will get the same thing that I got when you integrate with u substitution instead. I'm going to go ahead and simplify this a little bit by getting those negative coefficients to cancel, multiplying everything through by a negative. And of course, that constant times the negative is still just some sort of constant. This one was a particular solution, so we need to sub in that initial condition of 0, 0. We get e to the 0 equals 1/2 times e to the 0. E to the 0 is 1. And solving for c, subtracting that 1/2 from both sides. And writing our final solution, e to the -y equals 1/2 e to the -2x plus 1/2. All right, last one, again, starting off by rewriting that prime notation with a dy dx. Separating those variables, multiplying 16y to both sides. I'm just going to leave the negative with that 9x and multiplying both sides by dx. Integrating, we get y squared, and then dividing that 16 by 2, we get a new coefficient of 8. And then we'll have a -9/2 x squared plus c. All right, since I'll be subbing in 1, 1, and I don't want to deal with the fraction, I'm going to go ahead and clear that now, multiplying everything by 2. And of course, a constant times 2 is still just some sort of constant. All right, now I'm going to go ahead and solve for that particular solution, subbing in 1 for y and subbing in 1 for x, adding 9 to both sides will give me a c value of 25. So my final differential equation would be 16y squared equals -9x squared plus 25. All right, I've got another question for you. My question is, what is the worst part of this quarantine for you? For me, it is the fact that I cannot get my hair cut. I needed a haircut back in February, but I'm one who waits too long as it is to get a haircut. So by the time I tried to schedule it, I couldn't quite get in during spring break. And then everything shut down and I have been unable to get in since then. So my hair is absolutely driving me crazy. And to be perfectly honest, if any of you know of someone who's giving bootleg haircuts, I'm in. I need a haircut so desperately. So now share with me, what is the worst part of quarantine for you?